or for one or two of you, good evening, I guess. Welcome back to our second day of our virtual symposium on farm animal cognition and its implementation into animal husbandry and management. There are three short things I want to mention before we start with the plenary. The first is that you've been already noticed that there's a small change in schedule. I will send a link in the chat box today so you can access the changed schedule there as well if you haven't received this yet. I just want to, on a second note, briefly remind you on the housekeeping rules. Please take care that your microphone is switched off. And if you have questions to the speakers after the presentation, please raise your virtual hand with the below icons. If you have problems raising your hand, this might happen if you have an older Zoom version, please contact our technical support directly in the chat box, and they will guide you how you can find alternative ways to raise your hand or show emoticons. The third thing is a quick mention of our breakout rooms today. We had some yesterday, but realized there was some problems in the communication, but also in the coordination, so people were not able to access them by themselves. This problem should be fixed today. So during our lunch break of 90 minutes today, there will be 3 breakout rooms. Feel free to join them to have more informal chatter about different topics. And again, here our technical support will provide more details on this. And if you have problems joining, contact our technical support and they will help you and guide you on this issue. With this being said, we are going straight to our first plenary speaker of the day, and our plenary speaker of the day, Fay Clark from the United Kingdom. I'm very happy to have her here today for our symposium. Fay has worked for Bristol Zoo previously, and she's now affiliated with the University of Bristol. Her research focuses on the link between animal cognition and animal welfare. She's running projects on primate and dolphin cognition and welfare, but she's also assessing the impact of cognitive enrichment on various zoo animal species. Her plenary, as you can see from the slides very soon, will focus on the latter topic. With that being said, the screen is yours, Fay, and I'm looking very much forward to your talk.
Thank you very much, Christian. So let me share my screen. Okay, so it should be coming up. Can everyone see that?
Yeah, I think you have to full screen. Yes,
there we go.
Wonderful.
Excellent. So yes, thank you so much for inviting me to give this plenary this morning. And when I was looking at the list of delegates, I noticed just how many people that are here at the conference today I have cited in my own work on zoo animal cognition and welfare. So it's quite scary actually to talk to so many of you that I admire in the zoo world, sorry, in the farm world. So yes, without further ado, I have 3 sections to my talk this morning. So I will start off telling you, setting the scene really, what it's like to work in a zoo setting and the differences I think that are very important that we think about straight away. And then moving on to the study species and the particular methods and approaches that I use in my research. And again, thinking about the similarities and the differences with the farm setting. And then the bulk of my talk today will be a guided tour through various research projects that I've been doing over the past 2 decades now on animal cognition and welfare and where those 2 disciplines meet each other. How I developed a cognitive enrichment framework for zoo animals, and then my 5 key findings from the research that I've done. My research, and again trying to draw parallels with the farm world. And then I will end on talking about how I think we can make cognitive enrichment and cognitive challenges better, specifically in a zoo setting, but also I think that can be applied to different settings. And I will focus on trying to propose why I think we should think more about competence and agency moving forwards. So let's start by setting the scene and taking a look at what it's like to be a researcher in a zoo. I'm guessing that most of you don't have an in-depth working knowledge of this particular setting. You might have done a couple of research projects, but I have been solely based in zoos for almost 20 years now, and it's quite an unusual place to work. So what are zoos? And I mainly refer to zoos here as zoos in the UK and in the USA. So those are the two areas of the world that I've worked in. So the first thing is that zoos are menageries. So they are literally collections of diverse taxa. And your typical zoo in the UK houses around 400 different species. So there's our first big difference with the farm setting. Just the taxonomic diversity that we have in a zoo is really quite astounding, and that makes it quite difficult to study particular species. Then they are sites of conflicting interest. Zoos have various roles in leisure, education, conservation, and then maybe research, but research is not usually a primary aim of most zoos. So getting research done in a zoo setting can be quite challenging. A really difficult thing about working in zoos is that zoos are public spaces. Zoos in the UK typically are open every single day apart from Christmas Day. So there's no break to do your research. That's a little bit different to the zoos that I've worked in the USA, where they might be shut Monday to Thursday. And then the funding is really important to think about. So zoos in the UK are funded by ticket sales and also other charities. So the money that's coming in to fund your research is very, very low. As a zoo-based researcher, you are not eligible for government funding. You can't get Research Council funding. So just having the money to actually do this sort of research is very difficult. So there's three fundamental limitations of zoo research as my caveat, I guess, for the rest of my talk. As to why I'm working with such small samples and quite sort of low amounts of resources is, first, there is a small sample size because we're mainly dealing with highly endangered species that you might have only 50 to 100 left in the entire world. So that makes it very, very difficult to replicate your studies. There's definitely a lack of experimental control, things like doing your work out in the weather, having visitors come and just watch what you're doing can be quite challenging and very different from a farm setting. And then just trying to understand what all these different behaviours in your exotic species actually mean, because you've got this diversity. So a little bit more about my background and where I'm coming from. So my research has typically fallen into the three disciplines of animal cognition, animal behaviour, and animal welfare. And I found myself floating around these three disciplines. So as you can see, I've put some example projects on the slide on this Venn diagram. And then over time, I found myself drifting towards the center of the Venn diagram, so where cognition, behavior, and welfare completely overlap. And this is what I call the trifecta, cognitive enrichment. So that idea of linking in the cognitive skills to enhance welfare, and then we're trying to assess welfare through the proxy of behavior. And I would also say, if there's any sort of early career researchers in the audience this morning, and you know, you're thinking about your next steps and your next project, I found it really useful to put my career in a Venn diagram like this, because it really helped me to visualize what I've been doing over the past couple of years, where I've been drifting, and it also helped me sort of identify areas that might make interesting new projects and links that I could make with different researchers. Okay, so moving on to my study systems and approaches. So bit of a spoiler alert on the previous slide, you might have noticed quite a lot of projects on primates. So I've worked on a whole range of exotic species, and that's a great thing about working in the zoo setting. but my research has converged on great apes, lemurs and dolphins. And I actually started off working with dolphins. I was a dolphin cognition researcher before anything else. And then I started working with primates, and then more recently, trying to do some comparative research, so to compare the cognitive skills and the behavior and welfare of great apes and cetaceans. And if I had to sort of define myself, my role, my identity as a researcher, I would probably say that I use modular apparatus tasks. So a lot of what I do is building apparatus, and it's always modular in design. So it has these repeating components, and you'll see that on the pictures as we go through. I don't employ any animal training in my work, so I never train animals to perform a particular task. Everything I do is spontaneous. Again, that ties in with what you can actually get away with doing in a zoo setting. And another important aspect of what I do and my identity as a researcher is social group testing. So I never isolate individuals or move them between environments at all. I always do my testing in a group setting. Okay, so moving on to the cognitive enrichment framework that I developed over probably the past 10 years, I would say. So this all kicked off with my PhD, which I started back in 2010. And this was at the Royal Veterinary College in London in association with the Zoological Society of London. And as all good PhD students do, at the beginning, you start with a massive literature review. And it was very clear to me that cognitive challenge was a topic, it was a theme in the farm animal literature, and I was reading a lot about it from a lot of you that I'm speaking to this morning, but I wasn't seeing anything like that in the zoo setting. So I wanted to take what I was reading about in the farm setting and apply that to zoos. And I did that basically through a series of experiments where I designed and evaluated 3 different cognitive tasks for chimpanzees and dolphins. And then using that information, I tried to develop a new framework for cognitive enrichment. So this slide just summarizes really the literature that I based my PhD on. So I was basing it around the concept of cognitive challenge. So a lot of this literature, I'm assuming, will be very familiar to most of you. And then I teased cognitive challenge apart into its different aspects. So aspects of motivation, exploration, reward. And then the 2 that are in the middle, agency and competence, these were the ones that I was particularly interested in because there was really no research on these in exotic animals, so in animals that live in zoos. So these 2 things, agency and competence, were the things that I was particularly trying to study in my exotic animals. And the literature really boiled down to 3 things to me. So 3 really salient points from the literature. There were 3 overarching benefits to welfare that I could detect from cognitive challenge. So the first thing was that exploration, problem solving and play were intrinsically rewarding. So I was starting to think, okay, well, I think I can stimulate exploration, problem solving and play in my animals. Competence and agency are associated with good feelings. So I thought I could probably stimulate competence and agency, hopefully in a zoo setting. And then I was reading that competence is associated with long-term health benefits. So again, maybe I might be able to measure those things in zoo animals. Okay, so before we go any further, I just wanted to get people thinking, to get the sort of the brain going a little bit. So just things that you can think about in your own mind. And it's something that I call the dinosaur phenomenon. And this is something that I encounter as a zoo researcher. So let's just imagine that scientists are very clever and they manage to bring dinosaurs back from extinction. So dinosaurs are alive again, and we have sort of Jurassic Park style, we have a species of dinosaur, a small group of them, and we house them in a zoo. So that's all very exciting, but what do you think? Do you think we would know if those dinosaurs are suffering? Could we enrich them? What knowledge would we need on those animals to be able to enrich them? And is there a minimum sample size that we would need to be confident to run an enrichment study on those dinosaurs? And then finally, if we were to do that project, do you think that we could generalize the results from that one group of dinosaurs to any other dinosaurs that we managed to reincarnate? So the reason that I'm asking you to think about this is to try and get out of your preconceived ideas as to what animals deserve enrichment and what animals we can enrich, because I often find in the zoo world that the animals that I work with are treated like dinosaurs. They're treated like animals that are, some people say they're better off dead, some people say they're better off wild, some people say, well, there's so few of them and we know so little about these dinosaurs that it's really not worth enriching them, it's really not worth doing cognitive enrichment or cognitive studies because we can't generalize those results. So yeah, with that in your head, we'll move on to the next, the slides where I actually talk about what I have done on my so-called dinosaurs. So I'm going to show you some slide summaries, which basically summarize each project, each single project that I've been doing. And some of these are on my PhD, so we'll go over those first and then I'll move closer into the present day. So the first one, this is one of my PhD studies, and this was on chimpanzees at Whipsnade Zoo, which is part of the Zoological Society of London. And the idea with this particular study was to design, implement and evaluate two different novel maze tasks. And again, as I said, what I usually do is a modular approach. So the device is modular, it has repeating parts, and I give it to untrained animals in a social group. So there's no prior training or isolation or deprivation of any kind. And I'm focusing on competence and agency. So this study was done with the devices going in on certain days and then coming out. So it was an A-B design where there were baseline days in between the trials. And we were able to change the rewards, the type of reward, so whether it was intrinsic, so whether it stayed within the device or whether it went out of the device, which was usually a food reward, and we could change the complexity as well. So I'll show you on the next slide a little bit in greater detail what the first puzzle looked like. And I will say I find myself switching between the word puzzle, apparatus, device, task. They're literally all the same thing. It's just semantics, really. So what we have here is hopefully you can see the modular design of this thing. So it's an orthogonal maze. It's actually paving slabs. So this is the stuff that you put under your lawn or under your driveway to stop soil erosion. So it's a material that you can get very cheaply from a garden centre. And what we did was we loaded food into the top, and then the chimpanzee had to work those food items or tokens through the top of the maze to the bottom. And they could also use stick tools as well. And we manipulated complexity by blocking certain cells. So if you think about it as like a honeycomb structure for a beehive, you can literally lock certain cells into place so that the nuts can't go through those cells, and it just makes it more difficult for the chimpanzee to navigate. The middle picture is some recent work that I did in collaboration with Lincoln Park Zoo in Chicago. So not for my PhD, but I was interested in replicating this work. with a larger sample of chimps. And then on the right hand side, that's just another angle showing you a chimpanzee using their finger to navigate an item through the maze. And then the second device for the chimpanzees is not easy to see from the picture, I'm afraid. I think with hindsight, I should have got a proper photographer to help me get some images of these things. But it's made out of plumbing pipes, so again, a very cheap material to work with. It's modular. It has like a tree-like structure. With this particular device, we wanted to force tool use. So great apes do habitually use tools, particularly chimpanzees. So we made the access holes so small that they would have to go and find a stick to navigate the food or the tokens through this thing. And when they do so, they fall into a large container at the bottom. So that was the chimpanzee side. The dolphin side, so hopefully from this picture, and again, I do apologize, my own pictures that I own the copyright to, they are not nice pictures. They're not very detailed pictures. We actually had a National Geographic photographer accompany my research, and he got some gorgeous pictures that ended up in National Geographic magazine, but I don't own the copyright to those. So hopefully what you can see from this picture here is that it mirrors what I was doing with the chimpanzees. So it's a comparative task here. We gave literally the same task to the chimpanzees and the dolphins, apart from some anatomical differences. And again, same sort of aims with this one. So to design and implement and evaluate this task to see whether it could be a form of cognitive enrichment. With this particular one, we were focusing on problem-solving signals. So not a lot is known about dolphins' emotional expressions and indeed their welfare indicators. So we were very interested in focusing on what dolphins were doing as they were solving the problem. So were they indicating frustration or happiness or excitement as they were progressing through the task? Some more images of that task for you. So again, hopefully from these pictures, you can see the similarities with the chimpanzee task. And you can see that there's a channel cut out of the front of the pipe. So dolphins rarely use tools. There's a couple of examples of them using sponges in the wild, but they don't use tools in captivity. So rather than give them stick tools, which wouldn't be a fair task for them, what we did was we cut a channel out of the front of the pipe that allowed the dolphins to insert their rostrums or their noses into the pipe and move the ball that way. So the ball didn't pop out of the pipes. It ended up having to go all the way through the pipes, and then it came out of the bottom pipe. Another thing about this project was I looked a little bit at behavioral lateralization. So a fun fact about dolphins is that they tend to swim, they nearly always swim in an anti-clockwise direction in captivity. So when you have them in a pool, they swim in a certain prevailing direction, and that can get quite repetitive and stereotypical. So we thought, well, if we put something in there that is complex and it's in a central part of the pool, then potentially we could break up that stereotypical swimming pattern. So those were my PhD projects, and before I move on to talking about some other projects and the 5 key findings from all of them, I'll just stop and give you my definition of cognitive enrichment. So this was developed through the process of doing those tasks that I've just shown you. So the definition that I published back in 2011 is that cognitive enrichment engages evolved cognitive skills by providing opportunities to solve problems and control some aspect of the environment, and is correlated to one or more validated measures of well-being. And then a few years after that, I actually returned back to the definition after a bit more research and added a third aspect, which is reward. So cognitive enrichment needs to have some form of reward, but it doesn't actually seem to matter whether that is an intrinsic reward, so something internal like a sense of satisfaction, or it's extrinsic, so it could be a food reward or something else, or a toy that's actually coming out of you solving the task. So hopefully, if we think back to our dinosaur phenomenon, so the idea that you know, you can have really, really unusual, highly endangered, small sample sizes of animals, hopefully you'll agree that this definition could suit a dinosaur. And if dinosaurs did, you know, return to the planet and were alive again, it doesn't actually matter what species we're talking about. Any species can benefit from cognitive enrichment, and it is possible to study cognitive enrichment on literally anything. Okay, so then moving forwards into post-PhD world, I moved to Bristol Zoo Gardens and was there for 8 years. And most of the research that I did there on this topic was on gorillas. And we had a project there called Gorilla Game Lab. And this project has its own website, gorillagamelab.com, if you want to go and have a look at that later. So again, testing the same principles, the same ideas as I did for my PhD, but the difference with this project was that I wanted to incorporate some technology because, as you saw in the previous photographs, everything that I'd done up until that point was really quite low tech. And, you know, I was getting materials from garden centres and things given to me by donation and other charities. So I really wanted to up the technology with this project, but everything else, the aims and so on, are pretty much the same. So this was a really interesting project because it allowed me to collaborate with the University of Bristol, with product designers, engineers, computer scientists, psychologists, artists. So it was a really multidisciplinary project. So here is the Gorilla Game Lab device. It's about half a meter by 1 meter box. And inside the box, you can slot various puzzle modules. And each of these modules is completely interchangeable. So you can move the position of the modules within the frame. And you can also rotate each module by 90 degrees. So there's literally millions of potential iterations of this puzzle. But essentially, you know, the idea behind it is the same as the work I've had done before, where the animal starts at the top of the maze, it's modular, and they work their reward from the top of the maze to the bottom. But the unusual thing about this was that there was embedded technology inside the device. So there were two types of technology. The first was piezo sensors, which are little electromagnetic sensors that are very, very thin, about as thin as a piece of tin foil. And you can place them inside something like this, and they automatically record how the animal is using that device. So they will track the movement of the animal's hand and the reward item that's in there as well. So you no longer have to stand there and video record them and then code the data. It's all automatic. And then the second thing was a machine learning program. So if we take a look at the next slide, there was an outward facing camera, so just a GoPro camera inside the device that was recording the gorilla's face as they were using the device. And also there was another camera that was recording their side profile. And then with the guys at the University of Bristol Computer Science Department, we developed a machine learning program and then eventually a deep learning program to automatically recognize which gorilla was using the device. And then that combined with the sensor data was connected together and beamed to an iPad that sent the information to the keepers and to the researchers. So all of this information was completely automated. And then the final project that I've been working on is a little bit different because it links cognition, not with welfare, but with conservation. So one of the key roles of a zoo is to conserve endangered species ex situ, or in the zoo rather than in the field. But a big problem with zoo-based conservation is that we focus on conserving total numbers of individuals of animals rather than conserving their behaviors and conserving their cognitive skills. So we may be able to house quite large numbers of individuals in zoos if you add them all up across the world. But what we're noticing is these animals don't have what it takes to find their own food, to navigate their environment. So if we're going to reintroduce them eventually into the wild, they've got no hope. So this project was all about trying to assess the cognitive skills of captive lemurs, specifically ring-tailed lemurs, and then furthermore, see if we could use that information to challenge their cognitive skills over time. So to give them the survival skills that they were lacking before they're reintroduced. And so here we have a picture of the apparatus. So there's definitely similarities between this and the whole board task that we heard about yesterday. And you can test very, very similar things. So color cue learning, for example, so to bait one color and then the other color has no food behind it. So it looks a little bit like a giant advent calendar, 24 doors. 12 of the doors have a food reward behind them and 12 of them don't. So here we have it being put in with the lemur group at Wild Place, which is one of the zoos that Bristol Zoological Society own and run. And as you can see, it's going into the normal lives and the management style of the lemurs. So we're not doing anything like, individual testing or trials or anything. So again, very different to what we've heard about so far in this conference. And then I also went to the Lemur Conservation Foundation, which is a facility in Florida, where the lemurs live in massive pine forests, which is a really, really interesting place to go and do research, because the habitat that they're living in is a lot similar to what it would be to Madagascar. So if we're thinking about candidates for actually reintroducing to the wild, the lemurs that are living in Florida are presumably better candidates than the lemurs that live in Bristol. Unfortunately, there was a hurricane when I went out there to Florida, and I couldn't do the full setup. So this picture here on the right hand side shows a very quick rough and ready mock-up or example of what we had to do, and we did this inside the hurricane shelters at the facility. We couldn't go out into the forest because of the storm, but we just used floor tiles and the cones that you give to children to run around at school. So actually it just shows that you don't need very, very high-tech equipment or expensive apparatus. You can actually do these sorts of things quite cheaply. So yeah, before I move on to my 5 key findings then, if anybody is ever interested and wants a break for 5 minutes and you would like to design a module to go inside the Gorilla Game Lab device that I talked to you about, please do feel free. I can talk about this more in one of our coffee breaks maybe, rather than take up time now. But basically what we have is a 20 centimeter by 20 centimeter cube, and within that cube, we are asking people, so everybody, not just scientists, but school children, friends, family, students, to think about what puzzle you could put inside that module. And then that module goes inside the Gorilla Game Lab device. So yeah, it's just a very quick 5-minute brainstorming exercise. If any of you would like to do that and share your designs with me, we would love to get some input from people. Okay, so moving on to the 5 key findings then from the chimpanzee research, the dolphins, the gorillas and the lemurs, we see parallels across these projects. So I'll try and go through these as quickly as I can so I don't run out of time. Just checking my clock here. Okay, so the first key finding, and again, this definitely has parallels with the farm animal literature, is that the zoo animals would spontaneously problem solve. So we did not train any of these animals to use any of these tasks. And they used their own skills and worked it out for themselves. And they did come up with some quite ingenious ways of solving these problems that we weren't expecting as well. And we did see some convergence of skill use over time. So at the beginning, we saw a diversity of ways that different animals would solve these challenges. And then over time, they got better and they got more efficient, and they kind of converged on one or two successful strategies. Apes, so the chimpanzees and the gorillas, collected and modified their own stick tools. We didn't provide tools in the studies, so the animals actually went off into their environment, into their outdoor areas, and collected their own stick tools and shaped them according to what they needed. So they would sharpen the end of a stick tool with their teeth, or they would pull bits off to make it thinner, which adds another layer of cognitive challenge. So again, if we're thinking about this as being a form of enrichment, the animals are bolstering their level of challenge by having the ability to do this with tools. And then we have some ongoing data analysis that we are currently submitting at the moment, which looks at dolphin emotional responses to problem solving. So we think that the bubble that you can see in that picture there on the top right is indicating an emotional response to problem solving, because it's happening not in baseline, but it's only happening when the dolphin is engaged with that challenge. So the sort of conclusions from this particular finding are that it's not necessary to train animals to benefit from cognitive enrichment. And if you can provide raw materials, for example, if you have tool using animals, then you're only going to increase or add an additional layer of cognitive challenge onto your study. The second thing that we found is that animals do not need an extrinsic or an external reward. And I know that this is in contrast actually to some recent research in the farm world, but we found that our chimpanzees were more motivated by the tokens than the nuts. And dolphins were more motivated by a ball that was inside the device than a ball when it was released from the device. And we also had one of our female gorillas who was not interested in eating the nuts that she extracted at all. She actually made a little pile of them next to her and left them for hours, and then only ate them when her regular meal time came. So she was not interacting with the device at all for food. So it's not necessary to have a high food reward or deprive zoo animals before trials. So we found that we don't need to change their normal diet or put their normal diet inside these devices. And quite often when the food comes out, they won't even eat it. Number 3, animals were moderating their own level of challenge. So this is the brilliant thing about designing something that's modular. So if you're giving animals choices as to how complicated that task can be, the animal itself will choose how it participates. So if you imagine that you've got a vertical maze and you've had an animal that's already been and done a bit of the challenge and moved a nut or a token maybe halfway down, and then they've got distracted, another animal can come up and finish the challenge. So it's not a full challenge for them, but they're still participating at their own level. Another thing that we did with the gorillas was that we gave them different runs of challenges. So we gave them a vertical section of the device that was simple, a vertical section that was intermediate, and a vertical section that was hard. So you can see those different runs in the picture on the top right there. And what we found, interestingly and quite unexpectedly, was that the gorillas opted for the middle level of challenge. So not the very simple one and not the very difficult one, but what they perceived to be difficult changed over time. So it became less difficult for them over time. So their preference sort of moved, if you like. So that shows that their challenge level changed the more they'd had exposure to the device. We saw that lemurs adopted producer and scrounger strategies. So the way that they were using the task mirrored how they would forage and their social hierarchy. And again, remember, this is all social testing. So they're all participating at the same time. But we noticed that some lemurs would wait and hold back and would prefer to do the simplest end level of the challenge, and the more dominant lemurs would actually do the bulk of the problem solving. And then the final thing is, interestingly, the gorillas shared their time using the device. So we didn't see any aggression, no monopolization. The gorillas came and went one by one, or sometimes they would do it as a mother and an infant pair. That's what the graph at the bottom is trying to show, the barcode graph with the names of the gorillas down the side and the trials across the top. I hope it's okay to interpret the graph for you, but essentially what's happening is the gorillas very patiently wait for their turn to use the device in a group setting. So we did not feel the need to isolate them and look at them individually, because they sort of did it themselves. Number 4, challenge can have knock-on effects. So we noticed that even when the challenge wasn't present, exploration was increasing in the baseline days in between. It also increased social play. So those are the 2 key things when we're thinking about increasing animal agency. It's the play and it's the inquisitive exploration that we wanted to stimulate, and we did actually manage to do that. So that's great news. And we also think that with the gorillas that weren't using the device at the time were benefiting anyway, because they were getting some peace and quiet. Because sometimes in a zoo setting where you've got a small enclosure size, it can get quite tense with all those animals together, and they don't have the space to release those tensions. So if you have something like a cognitive challenge that can keep some animals entertained and occupied, even the animals that aren't using it can still benefit, because their social tension is decreasing. And then the 5th and final one is about technology. So incorporating the technology into the gorilla device was a lifesaver, honestly. The amount of data that we suddenly could amass just from these simple sensors and the machine learning program was just amazing. And we have published that machine learning program. If any of you happen to work with great apes, you're more than welcome to use that program. It's available open access. But I think now that I've had that experience of technology, I will just want to keep using it always now, and embed automatic sensors into my cognition devices. Just a very quick shout out to other zoo-based cognitive enrichment researchers out there. So there are a few of us, there's not many of us, and there was none of us before I started my PhD, but I think things are improving now. So there's loads of examples of great ape and monkey touchscreen systems that are being used in places like Zoo Atlanta, Lincoln Park Zoo, Melbourne Zoo use the Microsoft Connect system with their orangutans. So it's not a touchscreen system, but it is projected computer images into the enclosure. We even have a remote control feeder ball that a pet food company developed with San Francisco Zoo for a rhino, and tying in acoustics as well. So thinking about cognitive enrichment for animals that are very acoustically sensitive, such as elephants and their ultrasonic communication. There's been some work done with Scandavale and the Open University in the UK. And then the final part of my talk is just thinking about reflecting on what I've done, what I've managed to achieve in a zoo setting, and how we can make cognitive enrichment better. But I think this could have applications for any animal setting, really. And again, going back to the dinosaur phenomenon, it actually doesn't matter, in my opinion, how many animals you have, where they've come from, where they're housed, how endangered they are. or anything like that. I think every animal, going back to Rebecca's plenary yesterday morning, any animal has an intrinsic value and it deserves our attention. If we're going to manage it in a captive setting, it deserves for us to at least try to do cognitive enrichment, even if we don't have a lot of background information. So my three conclusions are that cognitive enrichment is not normal enrichment. So I like to separate it from other standard enrichment types. And I think it's really important to draw from the cognition literature if you can, and spend a lot of time developing what will be relevant and appropriate for your study species. I think we should zoom in or focus in on how the subject uses the task and not just if. So again, if we use modular devices, we can have a really good look at the sequences of problem solving, not just a task which is binary. Yes, they did it. No, they didn't. So that's another reason why I really promote the use of modular tasks. And then finally, I think we also, as well as zooming in, we need to zoom out, and we need to zoom out on the concept of agency. So have a look at how the animal is behaving in its wider environment after this period of cognitive challenge. Does it impact how inquiring they are in their environment, and does it impact on their playing, which in a sense, many people say is them preparing for future challenges. So yes, my proposal to everyone really is that we need to do more on competence and agency. And I love this quote from Spinker and Vemerswelder, who say, do animals interact resourcefully and playfully with their environment? Are they busy and absorbed in organizing their lives? This is the ultimate goal. And it doesn't matter to me if this is a bunch of dinosaurs in Jurassic Park, or it's a bunch of zoo animals, or it's a bunch of farm animals. I think this aim extends across the animal kingdom and the setting. So cognitive enrichment in zoo animals is difficult for sure, but it's not impossible. More cross-fertilization is needed between farm and zoo scientists, and there is big scope for looking at competence and agency. So if anyone is interested in that, as am I, I'm very open to talking about collaborating. So thank you very much for listening, and thank you to everybody that's been involved in my research over the past couple of years, people who have funded and the zoos that I've worked with. And please just note that my email address is a little bit different from the one in the abstract booklet. It looks the same, but it's slightly different. So I'm at Bristol University now, not Bristol Zoo. So I've put it on the slide for you. Thank you.
Thank you, Fay, for this very comprehensive and clearly structured talk that definitely gave a lot of food for thought to the many participants here that work on farm animals. So let's go to the question and answer. I already see two raised hands. Jean-Loup was first, please.
You have to go. Rebecca can go. I think we always compete. Do you want to go, Rebecca?
I hadn't actually raised my hand yet, but
I thought you did.
No.
Maybe it was a clap. I think they look similar. So.
Yeah. But just to say, this was an amazing talk, and I'm really happy to see that. I mean, there's so much to think about in terms of what can we do getting cognitive enrichment into the farms. The problem with working with pigs is always that they destroy everything. But I can't imagine that's a whole lot different with primates. I mean, they must.
Absolutely, yeah. I'm working with really, really strong animals. So the gorilla is 6 times stronger than man.
Yeah.
So absolutely, I think if I can get things in with gorillas and dolphins as well, I think pigs and cows can be managed I've upscaled my devices as well for elephants and killer whales, and it's literally the same design, but the construction is different. So we've gone from plastic to metal. But
but thinking about it in terms of enrichment, it would have to be something that's a little easier to produce. I mean, I'm sure that we have made things that can be used to test pigs in experimental settings, but I think the idea of looking at this as something that you could make modular and maybe implement on farms is a lot more interesting, because it's something that could be done to improve the lives of pigs on farms or other animals on farms. And you know, do people do this with birds? Could I do this with a chicken? All right, I'll let other people ask questions as well.
Jean-Loup, now it's your turn.
I'm not sure. Yes, gorilla has a stronger force than other farm animals, but I also think we need to consider we had the bad experience that a herd of 60 goats can destroy a whole apparatus in less than 5 minutes, or 10,000 chicken can also be pretty hard on a tree over time. So I think farm animals are maybe less enriched, and they have a lot more time to destroy things that we provide them. Now, my comment was more on so it's interesting, you presented these puzzles that you give to the lemur or the primate and so forth. And we often get this question of how relevant or like natural are this paradigm for the animal, which is a whole philosophical discussion. And I don't think we necessarily need to get into that, but you presented it also within the context of conservation. And if we reintroduce this animal, we are training them on this task. And I was just curious, do you know, like, okay, is it just an assumption, or has it been proven? And is there studies that looked at how well do they perform on this kind of more theoretical task, which will develop some theoretical skills? And how does this apply to real life environment when you have to fight for survival and food and things? So I guess the same thing as when we train our students to learn something, and then when you go in the real job, you know, it's useful to them.
So there's not been much. Most of the work looking at challenges come from the laboratory setting. So to challenge an animal and then obviously to put it in an open field, which essentially is simulating the wild, and see how it performs and compare it to animals that weren't trained or challenged. In a zoo setting, we don't have anything apart from in the 1980s and 90s, zoos in America started releasing golden lion tamarins, which is a small neotropical primate, back to Brazil. And they noticed that when they reintroduced them to the wild, they were literally falling out of the trees. And the reason why was because these primates, when they'd been reared in the zoo setting, their habitat was static, so they had no experience of wobbly branches. So the way that trees actually move in nature is, you know, they flex, the branches have a give to them. So something as simple as that, you know, we have that data that shows that they didn't survive, basically. And it was something as simple as it didn't even get as far as them not finding food. They couldn't walk in nature because they didn't have the experience of how nature moves. So we have a lot of evidence supporting why we need to do it, but what we don't have yet is that data, as you say, where we actually experimentally test it. But it is very difficult because of the ethical concerns of preparing animals in the zoo to go to the wild. We can't prepare them for predators because of ethical reasons. We can't deprive them of food or make them find their own food because that's unlawful. We can't do that in the UK. It might be different in different countries. All we can do is try and train them in a positive way. But yeah, this is hopefully the direction that zoos will go in.
Constanze, it's your turn.
Hello, good morning. Thank you so much for this wonderful talk. It was very interesting. And my question is very close to the previous question. So you talked about that your rewards don't necessarily have to have an intrinsic value for the animals. Mm-hmm. And I found this very interesting. And I was wondering whether this also has to do with the environment of the animals, because as you said before, they really kept in a very good environment and all the needs of the animals are basically covered in the zoo environment. So would you expect that this may differ if they're not kept, or if the environment does not cover all the needs the animals have? Would they then also go for rewards that are have a higher intrinsic value?
Yes. So yeah, the problem, I guess, with doing research in a zoo is, again, the ethics make it difficult for you to study any effect of deprivation. So you could never study in a zoo setting what would happen if you put all of the animals' food inside a cognitive task. All of the food that we can give them has to be supplementary or up to 5% of the daily diet. So we could take 5% of what they would normally get and put it inside a device, but no more. So testing the effect of food motivation is going to be impossible. You'd have to do that outside of a zoo. So the animals, obviously, they know that they get fed 3 or 4 times a day, and it's literally handed to them in a dish. So their motivation to extract food from a device for nutritional purposes is really, really low. But the flip side of that is it shows that, amazingly, they will still engage with these tasks, even though there is literally no point other than the challenge of the challenge. So it's the intrinsic challenge. So that's what it's demonstrating. So it is interesting in itself.
Yeah, it's really interesting. Thank you so much. I found this very thrilling, and I agree with you. And I think we all have the problem that it's very difficult to construct, or to with animal welfare regulation, it's really difficult to get permissions for any kind of experiments where you comprise animals of any kind of need. So maybe we never find the answer for this, but it's interesting in itself. So thank you for pointing at this.
Thank you.
Okay, we have 3 minutes left. Let's see how many questions we can take in. Sandra is next.
Yes, thank you, first of all, for this really inspiring presentation. And I have a lot of ideas now. The question, I would actually like to challenge this idea that just because the food isn't eaten right away, that it isn't a food reward in itself. I mean, don't you think that just via classical conditioning, there is this connection between food for later? I mean, if they eat it later, I think the food can still be perceived as a food reward right away, even if they don't eat it right at that instant.
Yeah, so that happened. So one female gorilla cached her food or stored her food to the side, and it was one gorilla out of a total of 7. So because we have such a small sample size, and because zoos are not a fan of reproducing studies, replication just doesn't happen, because it's the magpie effect. Everyone wants to do the shiny new project, not replicate the one that's already been done. We don't really know if that was just a really odd thing that one gorilla in all of the gorillas will do. Caching is really, really unusual for gorillas. Gorillas do not cache food. So again, it could be an artifact of a captive gorilla who's very strange and not representative of other gorillas. But also I counter your argument by saying that maybe animals in captivity, particularly in zoos, overeat. So they will eat when there's no need to eat because they've got nothing else to do. So it's absent-minded ruminatory behavior. And we see that with gorillas, not these gorillas, but lots of gorillas regurgitate and re-ingest their food. So it's a ruminatory stereotypical behavior that's quite common. It's so common, in fact, that we consider that part of their normal behavioral repertoire in captivity, even though we don't really see it in the wild. So basically, I guess the bottom line is how much an animal eats in a zoo is really difficult to interpret what that means. Because being in a zoo and feeding animals in a zoo is so unusual.
Thanks. I've seen that Jan and Rebecca lowered their hands again, probably due to the time. I just want to remind you that there will be for sure time during the lunch break to have a quick chatter with Fay about her research if you have more questions. And as we've been doing this yesterday, there will also be some time during the discussion round, during the roundtable discussion, to ask questions to the speaker that have not been answered. This being said, again, Fay, thank you for this excellent overview and presentation. I think it was a great pleasure for everyone to see your research and the development of your research over the years.
Thank you.